All right, welcome back to our lesson on a review of writing formulas. And I apologize ahead of time. Got the light in my eyes. I'm using the overhead because the new boards in the new building aren't fine-tuned yet, and it's just not working very well. And I wanted to get the video done before school started, and it's going to take a little while to kind of get some of the tech stuff kind of tweaked and troubleshooted, things like that. So it just doesn't seem to be working well with the new boards. So I'm doing the best I can with the overhead. I realize there's some light in the screen on the video. Hopefully the quality is good enough to get this across, and the light's in my eyes, so we'll do the best we can. But we did this last year, spent a lot of time on this last year, so it should be pretty familiar. So, okay. So writing formulas and naming compounds if you're given the formula. There's two types, and probably, I think what I'll do is start with the third page. And on the third page, probably the key thing, if you remember from last year, as far as determining what type of compound it is if they're both from the right side of the table. So keep that in mind. Where are they located? Both from the right side, you're going to use your molecular covalent rules. Those are your prefixes. Those are your dyes and your tris and that kind of stuff. So, okay. So both from the right, you're going that way. Pretty much everything else, you're going to use your ionic rules. Those are your charges and crisscross. So charges and crisscross. So first thing you want to take a look at is where they're at on the table and go from there. And I actually have a spider web. There's actually a spider web up here somewhere. I'm not quite sure where. You can kind of see it in the video. But anyway. So keep in mind on that. And don't forget, sometimes you'll have the eights and the ites, and those are your ionic rules. Which again, those are just charges and crisscross also. And I gave you a polyatomic sheet in class, and you're going to have to memorize a few of those. So, okay. Going back to the first page. So going back to that first page, let me erase the board. I forgot to erase the board. These are ionics. And again, these are left and right side of the table. Be careful on the ones in the middle. Could have more than one charge. Remember, those are on your polyatomic sheet. And polyatomics. So what I like to do is I like to make sure that I crisscross the numbers. It's kind of wordy, but just to make sure that the charges are correct. So for the first one, NaCl, this is if we have two elements. Na is a 1 plus and Cl is a 1 minus. Nothing written down below, no subscript down below. You assume it's a 1. And so the question is that true? So you can go to your periodic table. We wrote the charges, the oxidation numbers on the top of the column. And sodium, Na is a 1 plus, and the chlorine, the chloride is a 1 minus. So you're good to go. So it's just sodium chloride. And you know that. NaCl is a really common compound. But just kind of review those rules. And for that second one, again, the reason why I like to crisscross the numbers is to verify those charges, make sure they're correct or not. And I know a lot of people did this in their head last year, and that's fine. But the question you're asking yourself is iron a 2 plus, and is the Cl a 1 minus? We already know the Cl is a 1 minus from the previous one. So is there such a thing as Fe 2 plus? And hopefully you realize, hey, it's in the middle of the table. Siren's going off. Woo, woo, woo. Something's up. Red flag. So you go to your polyatomic sheet, and iron could be either iron 2 or iron 3. And Fe2 does exist. So if there's more than one type, you have to tell me what type it is in parentheses. So it's iron 2 from the charge, chlorine. So not too bad. Should be pretty relatively. Just a quick review for you, maybe to kind of get you going there. So, okay. So that's for the formula to the name. Name to the formula. Oh, I'm sorry, for 3 or more elements. So we did 2 or more up top. You may want to do these other 2. And then the last part of the video, I'll put up the answer key, and you can check your answers there. So if there's 3 or more elements, odds are it's going to be on the polyatomic sheet. Well, it will be on the polyatomic sheet. So, so uncrisscross the numbers. So in this case, Al is a 3 plus, and NO3 is a 1 minus. There's no subscript below the Al. So you got to ask yourself, does that exist? Is aluminum a 3 plus from your polyatomic sheet? Yep, it is. And is there such a thing as NO3 1 minus? And hopefully you realize from your polyatomic sheet there is. So that compound exists. And I got to look at my notes. I don't have the polyatomics memorized. Forgot them over the summer. So aluminum nitrate. And so that does exist. So Al NO33 is aluminum nitrate. Cu2SO4, this is a good one. So what a lot of people will do is think the Cu is a 2 plus and the SO4 is a 2 minus. And there is a Cu 2 plus, it does exist, but there is no SO4 2 minus. So if it helps you, think of the polyatomic in parentheses. This is one of the harder ones. So nothing's outside of here, so that's assumed to be a 1. So Cu is a 1 plus, and SO4 is a 2 minus. And now ask yourself if that exists. Does that exist? And Cu's in the middle, siren's going off, could be more than one charge, and lo and behold it is, there's a copper 1, and SO4 2 minus does exist. So, can you tell me which one it is? Copper 1, sulfate. Okay. So, if you want, go ahead and do those bottom two, and then you can check the answers at the end. So, hopefully this kind of refresh your memory a little bit. Going the other way around, maybe a little bit easier. So if you're given the name and go to the formula, if you're given the name, just write the symbol with the charge and then crisscross the numbers. Reduce if needed, so be careful there, don't forget to reduce. So, okay, magnesium fluoride, go to your periodic table. Magnesium is going to be on the left side. It's an oxidation number, charge of 2 plus. Again, it wants to lose 2 electrons, that's why it's a positive. Fluoride, F, is a 1 minus. Wants to gain 1 electron. So remember, this is an exchange of electrons. And so you got your oxidation numbers from the periodic table, and you can go ahead and crisscross those numbers. Or like we did later on in the year, remember, we exchanged electrons using the tennis balls. Magnesium wants to give up 2 electrons, 2 tennis balls. The fluoride wants to gain 1. So you need 2 fluorines for every 1 magnesium. So it'll only react or only get together and form a compound at a 1 to 2 ratio. 1 to 2 ratio. Iron 3 chloride. Don't worry about the ferrochloride part, but iron 3, so that's Fe. The 3 tells you the charge, 3 plus. Chloride, Cl, is a 1 minus. So go ahead and crisscross the numbers, FeCl3. Good one on that. So again, if you want, you can practice these bottom two and go ahead and take a look at the answer key at the end. Stop the video if you need to. If the name contains a polyatomic, ends in 8 or 8, you're going to need to go to the polyatomic sheet. So go ahead, and the first one will be similar to what we've been doing. So calcium is Ca. It's in the 2 plus column. Nitrite, go to your polyatomic sheet. And again, I don't have these, should have these memorized, but forgot them over the summer. NO2 minus. So the I tells you on the polyatomic sheet. Crisscross the numbers. I need 1 Ca for every 2 nitrites. Or think about it. Ca wants to give up 2, the nitrite wants to take 1, so you're going to need 2 nitrates, and that's when you pull out your polyatomics. Once you write the formula for the polyatomic, it never changes, so you're going to need your parentheses. So if you need more than 1 of the polyatomic, you pull out your parentheses. Lead 2 phosphate, that is symbols Pb. 2 tells me it's a 2 plus. Phosphate, PO4. Excuse me. PO4 3 minus, and so crisscross the charges. You need 3 leads for every 2 phosphates. So 3-to-2 ratio. Gives up 2, takes 3, so it's definitely not a 1-to-1 ratio. You're going to need 3 leads and 2 phosphates. Yep. We didn't do any reduction in there, so make sure you're aware of that. So if this was 3 and 3, we reduced to 1-to-1. 2 and 4, we reduced to 1-to-2. So just be aware of that. There weren't any examples here. I think a couple of these others may have an example on, so take a look at that. Okay. So those are, real briefly, a quick review of the ionics. Go to the second page, and we'll briefly review the moleculars of the covalent. Again, these are sharing. It should be shared pairs of electrons there. And these will be from the right side. Remember, there's a little bit of an exception with hydrogen. Hydrogen's a little bit weird. We'll get into that more this year. Okay. You're going to use the name of the elements. The prefix is based on the subscripts. You have the prefixes. Second element ends in IDE, so that's similar to before. Again, the only thing weird is mono on the second element only. So you know that from hopefully CO, it's carbon monoxide. Not monocarbon monoxide. So just keep that in mind. N2O5, so 2 is dinitrogen. 5 is pentaoxide. So dinitrogen, these are pretty easy. Dinitrogen pentaoxide. NO, we kind of already did something like that. That's nitrogen monoxide. CCl is carbon monochloride. Just to be consistent, you can do these two down here if you want. Going the other way around, if you're given the name, go to the formula. These are pretty straightforward. My board's not erasing super well. Tetrasulfur, so you know there's sulfur in it. The question is, what's the prefix or the subscript? Tetra is 4, so S4. Oxide is O. Tri is 3, S4O3. These you don't reduce the coefficients. Kind of weird. It's just the way it works. So this one down here, tetrafluoride, octaoxide. Tetra, again, is 4. Octaoxide, octa is 8. F4OH, we don't reduce. Ionics, we would go ahead and reduce. Molecular covalents, we don't reduce those. Okay. Should be a relatively quick review of those. Again, do those others if you want, and then you can check the answer key. We talked about this page already, the hints. We kind of went through that. And then that gets us to the acids at the end. Let me just say this, I don't have notes on this, but naming bases are the exact same rules we used on the front page. So they'll all end in hydroxides. We'll do more with acids and bases later on, but they all end in OH, the ones we're going to do, and they end in hydroxide. So you just find your charges and crisscross. Bases make sense. That's what we did on the first page. Acids are goofy. And if you remember, I said several times last year, acids are stupid. So in order to identify it's an acid, for what we're doing, it'll have a hydrogen out front. And it'll say aqueous, so it's a compound that produces hydrogen ions in water. And we'll get into more of those rules later on. So they're kind of goofy. 2 atoms versus 3. I think it's really kind of weird. I don't know why they did this, but it messes people up every year. So if there's 2 atoms, 2 elements, instead of hydrogen, you use hydro. And the second element goes to IC. And so instead of saying hydrogen chloride, first element goes, the first part's going to go to hydro. I don't have a ton of room here, so I'll just do it on 2 lines. And instead of chlorine or chloride, we're going to go to hydrochloric acid. We used that several times last year. We'll use it several times this year. You should be familiar with that. HF, hydrofluoric. Okay, so pretty straightforward there. But what's goofy is 3 or more elements. If you're going with a polyatomic, you don't use hydrogen or hydro. So we just said use hydro if it's 2, 3 or more, you don't go that way. So that's really goofy and it messes people up. So 3 or more elements, 3 or more atoms, this part won't really erase very well, but you do not use hydro in the name. The key is the polyatomic. And I don't have this written very well in here, but the polyatomic, this is, I need to rewrite this, or redo these notes, but if the polyatomic ends in 8, the name goes to ic, and if the polyatomic ends in ite, the name goes to OUS. I should redo those notes so it's a little clearer. So. All right, so I'm not worried about the hydrogen. All these are going to have hydrogen out front, so I don't worry about that. Don't use hydrogen or hydro in the name. The key is the PO4. So what is, and if you uncrisscross the numbers, the subscripts would be H1 plus PO4 3 minus. So the question is, what is PO4 3 minus? And if you look that up on your polyatomic sheet, it would be phosphate. So there's your 8. So right away you know 8's going to go to ic. So this will be phosphic. Remember, no hydro, phosphoric acid. That's goofy. It's just the way it works. Okay. H2SO3. Again, H is a 1 plus. SO3 in this case is a 2 minus. And so you're going to be looking up the SO3. That's sulfite. In this case, it goes to us. Sol plus acid. Okay. You're going to have a few of these. I don't have any extras to practice. I should add these on there, but you'll have maybe do a couple in class. You'll have a few on the homework, so you can kind of take a look at that. But how do you recognize it's an acid? It's going to have the AQ. I should have mentioned that. It'll have AQ. Versus other phases would be gas or solid. If it's a gas or a solid, use the rules from the first page. If it's a gas or solid, this would be, hydrogen phosphate. Gas or solid, this would be hydrogen sulfite. So it's goofy. Come see me if you struggle with that a little bit and need a little bit more review of that, or struggle a little bit with the homework. Going the other way, it's probably almost a little bit easier. So hydrobromic acid, you know all these are going to start with hydrogen, so it's H1 plus. You just need to look up the symbol and the charge for the second part of it. It's bromic is bromine, so it would be R1 minus. Crisscross the numbers. That reacts and forms a compound at a 1-to-1 ratio. And one key is make sure you put the aqueous in the end. Put the aqueous in parentheses, just to emphasize that it is an acid. Okay. Hydroiodic, H1 plus. Again, all of these are going to be H1 pluses at the beginning, so I'll just do that right now. Iodic is iodine, so crisscross, HI. Iodine is a nice charge on the right side of your table. Not too bad. Perchloric, so like we were saying before, ic goes to 8, so we're going to look up perchlorate. So that'll be my polyatomic. And perchlorate is ClO4 1 minus. So now I can crisscross, and we realize they reacted in 1-to-1 ratio. Okay. Nitrous, so us is the key there, X the key there. So us goes to ite, so I'm going to look up nitrite. Okay, because the us indicates the ite, and nitrite is NO2 minus. Crisscross, so 1-to-1 ratio, HNO2 minus. So again, those acids are kind of goofy, and you're going to see a few of those on your homework. So again, if you need to, come see me. Look at the link on naming acids on my webpage, or look at, do a little Google search on naming acids. So let me go ahead and put the answers to those, if you had worked on those other ones, and then we'll finish up. Well, there's the first page. Nope, that's the acid page, my bad. That's the last page, so I'll leave that up. That's the acid page. We pretty much went through all those. I added a couple extras. No, I didn't add any extras in there, so. But anyway, that's the last page. There's the first page. So if you did a few extras, you can check those. Pause the video if you need to. And there is the molecular covalent page. Again, you can pause the video if you need to. All right, so thanks. I didn't want to make the video too long, so went through that pretty quickly. Hopefully I wasn't too rushed. And we'll talk a little bit more about some of this stuff in class. Thanks.